Hello. In this video, we're going to start looking at operating on two functions. And what I mean by that is adding, subtracting, multiplying, or dividing functions. So if I want to add two functions, what I'll do is I'll look at some point and I'll add what those two numbers together are for that point. So just very quickly for this example, if I want to add these two functions together, I could add just x squared plus x cubed plus 2. I could add them in general. Or let's say I wanted to add these functions at x equals 1. Well, what I would do is figure out what each function is separately at 1. And add them together. And what you'll notice is it doesn't matter if I do that first or if I added them in general and then plugged in 1. These are actually going to be the same thing. So it's not very difficult to add functions or subtract them, multiply them, or divide them. It's actually something that's pretty common that we've kind of been doing without even realizing it. Now, we do have one tiny little issue. We have to be careful with one of these four. And of course, it's the fraction that's going to cause us some issues. We want to make sure that we're not dividing the two functions when g is 0, and when we're plugging in some values and it makes that function 0. So, our first task, beyond just adding, subtracting, multiplying, or dividing these functions, would be to figure out what is the new domain after we do this. So let's take two examples, or let's take some examples. So if we have x squared plus x cubed plus 2, the domain of x squared is negative infinity to infinity. The domain of x cubed plus 2 is also negative infinity to infinity. And so if we add them, subtract them, multiply them, this new domain is still going to be from negative infinity to infinity. Right, so if we, let's call this f and call this g. The domain of f plus g, the domain of x cubed plus x squared plus 2, would still be negative infinity to infinity. If we subtract them, we can see that's going to do the same thing. Even multiplying them, that give us x squared times x cubed plus 2, which is just x to the 5th plus 2x squared. And like we saw in that polynomial section, this is still a domain of negative infinity to infinity. Now, we do have this one little issue. The domain of f divided by g, because we'll want to make sure that g is not 0. So it'll be nearly everything, except we'll need to make sure we solve for where this is 0. Now, can we take the cube root of a negative number? Absolutely. That just comes out. So we have negative cube root of 2. So for this last example, all of these others, the domain of adding, subtracting, and multiplying these two functions was the same as the originals. This last one, we had this special case where we're going to have to throw out negative cube root of 2. So the domain would be negative infinity to negative cube root of 2, union negative cube root of 2 to infinity. So we have that one special case, but otherwise it basically looked like the domain of the original functions. Okay, but x squared and x cubed, they're not very interesting functions. Their domains weren't restricted at all. So let's look at something a little bit more interesting. The square root of x and x. So our domain for the square root of x is 0 to infinity. Remember, this is just whatever makes the denominator 0 and larger. And the domain of x is everything, negative infinity to infinity. So now we get to see what happens when these two functions mix. So, what is the domain of the square root of x plus x? Well, if we think about this, what are the x values we're not allowed to plug in? They're the ones that we're not allowed to plug into the square root of x. This domain is going to be the same as the square root of x. And if we're subtracting them, same thing. If we're multiplying them, I'll write it as x square root of x. What are the numbers we're not allowed to plug in? Again, it's 0 to infinity. It's those same ones that we're not allowed to plug into the square root. And then finally, what if we were dividing the two? Well, we're definitely still not allowed to plug in anything that's less than 0, because then we'll take the square root of a negative, and that's not a real number. And this time we needed that special case where we're throwing away where the denominator is 0. So our domain changes slightly. So we saw this time our domains after operating on them was the same as this smaller domain, the domain of square root of x. So let's see one more example just to make sure this pattern continues. So in this case, we have two functions. The domain of the square root of x plus 3. Well, again, we're going to want to avoid this underneath the square root being negative. So 0 to infinity. And then for this function, the only issue we have is when x is 3. So it'll actually be from negative infinity to 3, union 3 to infinity. Now basically everything except 3. So now, the domain of adding these together. Well, we still have this issue with the number 3. We still have this issue with square rooting negative numbers. So our new domain, it looks like a combination of these two. So if we plotted this, the domain for the second one was an open circle and then everything else. And the domain for our first function was a closed circle or bracket and everything larger. So if we want to make sure that both of these are okay, what we're really looking at is this intersection between the two. Where do they overlap? And they overlap from 0 to 3. Right, we have it both here, but then we don't include 3. Union, 3 to infinity. And this is actually going to be our domain for all of it. For subtracting, and again, not much really changed there. For multiplying, again, you can see these two base functions, those domains are going to really decide everything. And then the only time that we have to be extremely careful is with division. But what happens in this case? Well, in this case, this division is actually key change flip. We'll actually get the product of these two things. So in this extremely weird case, we see now our only issue is with that square root of x. So this is an example of how dividing can restrict our domain. Of how this can remove values from our domain, and how division can actually add values to our domain. But in general, if I'm going to add, subtract, or multiply two functions, the new domain is the intersection of the old domains. So the intersection of everything and everything was everything. The intersection of 0 to infinity and everything was 0 to infinity. And the intersection of 0 to infinity and everything but 3 is 0 to 3 and 3 to infinity. And then division will look very close to this intersection. We may throw away some new values like we did in these two cases. We may even add in a value back, but it'll look very close to the intersection of the two old domains. And that's everything we need to know about the domain after operating on two functions.